Today on 6.6, we are going to be talking about complex numbers some more, but we are going to add trig to it. So we're going to continue our complex numbers. And add a little trig to it. So let's do an example. We'll say we have the complex number 8 minus 8 root 3i. If I were to graph that, remember my coordinates to that would be the x value is your real number, imaginary is your y value, so it'd be 8 comma negative 8 root 3. So then if we were to graph that, our number would be here, we'll go, so over 8, 1, 2, 3, 4, 5, 6. We'll assume this is 8. We'll say this is 8 here. And 8 root 3 is a little bit longer, so we'll just say this is somewhere down here is 8 root 3. So we'll say this is our point, 8 minus comma negative 8 root 3 is here, I. And this would be our absolute value, mine from yesterday. So let's see if we can write the trigonomic form of the complex number. So not just the absolute value, but then also on top of the absolute value, we can write it including the angles of our answer. So remember, it's 8 minus 8 root 3, 1, or I'll write this 8 minus 8 root 3i. So let's first, we want to find our absolute value, what this actual distance of the line is. So our absolute value, and we'll call this r, would be the square root of 8 squared plus 8 root 3 squared, which gives me about 64 plus 64 times 3, which is about 64 plus 192. 64 plus 192, add those together, that is the square root of 256. And we're going to check to see if 256 is a perfect square. And it is, so my r value is 16. My r value is 16, so that distance is 16. So now from there, just a little bit of show you what the trigonomic form is. Our trigonomic form is r times the cosine of theta times the cosine of theta. That is my x value plus I, since my I is my y value, my imaginary, so then it's sine of theta, which is basically what we're looking for here. So now we just need to find theta. With theta, we know that we have the coordinates 8 comma negative 8 root 1. But we want it into, in order to evaluate it, we are used to the unit circle. So we know the 8 comma 8 root 1. What we are actually looking at is here, if I draw this triangle here, right? The 8 being your x value, so 8, and this is negative 8 root 3, negative 8 root 3. So then if I scale this down to my unit circle, I can divide everything by 8. So here I divide it by 8, and I divide it by 8. I actually have, like so, we have a 1 and a negative root 3. Oh, a 1 and a negative root 3. That means that my y, of course, my y is negative. This is in the third quadrant, like so. 1 negative root 3, and I have a 2. So my angle technically is up here. If I drew this in terms of me xy, my theta is actually right there. If I go back to my original triangle, of course, that matches. My theta is technically, my reference angle is actually quite right there. This being across from 1, this is actually pi over 3, not 3, pi over 6 being a 30-degree angle, but I don't want pi over 6. I want my reference angle, which is right here. This is the angle that I'm working with. So that is 90 degree minus 30 degree, which is 60 degrees. So I want 60 degrees in the fourth quadrant. My theta must then be 5 pi over 3. So I have all the components to put into my R to my equation. So I have my R, which is 16. Okay, so I got down here, this is 16. And it would be cosine of 5 pi over 3 plus I sine of 5 pi over 3. Let's try a different concept now. Let's say we are given the standard form. We need to write the standard form given the form that has the angles in it. So let's say we are given 5 cosine of 135 degrees plus I sine 135 degrees, and we want to find the standard form, and we want to plot it. So first things first, we want to find the standard form. So first, we want to know what the cosine of 135 degrees is. Well, if I draw here, 135 is over here, and the reference angle to 135 degrees is 45 degrees. So this is actually 45 degrees. And so we got a 45, 45, 90. So that is pretty simple. So here, this is a 40, so the cosine is what? Negative 1 root 2. So the cosine is then negative 1 or negative root 2 over 2. I'm just going to write it as negative root 2 over 2 plus I times sine is positive root 2 over 2. Positive root 2 over 2 for 135 degrees. I'm going to distribute my 5, so it's negative 5 root 2 over 2 plus 5 root 2 ion by itself over 2. And that is my form, my standard form from the angles. And if I were to graph it, it is right there. It should look like this. Let's try a number that might not be so nice. So let's say we have 5 cosine 4 pi over 9 plus I sine 4 pi over 9. I'm gonna first figure out what 4 pi over 9 is, and I really don't know what 4 pi over 9 is. So what I have to do is I have to put that in my calculator. From my calculator, if I punch in radian mode, remember, be careful, you gotta put in radian mode, and I put in the cosine of 4 pi divided by 9. That gives me about 0.1736, and the other one sine of 4 pi over 9, so 4 pi over 9, it gives me about 0.9848, and then we want it into like 4 decimal places. Then we distribute the 5, so 5 times 0.1736. That gives me about 0.8682. So we distribute the 5 to each one of these. And 5 times this, it should give me 4.924 I. So this is what you would do if you don't know the actual value of the precise value of the reference angle. So if it's not a 45, 45, 90 or 30, 60, 90, we would just use the calculator. And I know that since my sine and my cosine are both positive, and positive, it has to be in this quadrant. It has to be in quadrant 1, just like so.